Okay. So very warm welcome to all of you, my dear students. A very warm welcome to all of you. So, guys, I am again here with you with our 75 hard days challenge in physics. Okay. So this is the 10th day of this challenge, and every day we are doing some good questions of physics for from many chapters. Okay. So in the same direction, guys, we are going to do some questions today as well, and we are going to solve them here only, and the live students can respond to me uh, whether they are able to do it or not. Okay. So we know like solving questions in physics is of utmost importance, right? And in this direction, we need to work a lot and be good in physics. Okay. So now, guys, my name is Dr. Umashankar. I am your physics educator. I am PhD and MTech from Indian Institute of Technology, Roorkee, and these are few more credentials of mine. Okay. So, guys, let's start solving some questions for today. Okay. So let's go with the first question of the day. Okay. So today we'll be solving some PYQs. So here we go with the first question. Let's try this question. I'm very sure we can do it. So this is a NEET PYQ. Let's try to solve this question. I'm very sure we can do it. Please go for it. Please go for it. Let's try to solve this question, beta. I'm very sure we'll be able to do it. Very simple question. Let's try it. So this is the question from the vector. Okay, so we know the cross product of the vector. So the moment of the force, okay, that is some sort of turning moment. So moment of the force is also a moment. Okay, let me explain this question to you. So the moment of the force, that is 4i plus 5j minus 6k cap at 2 0 minus 3, about the point 2 minus 2 and minus 2. Okay, so we need to do this question. Let's try to do this question. I'm very sure we can do it. Let's try to do it. So see how we can do it, beta. So the moment of the force at this is given by. So what is the moment of the force, beta? So the moment of the force, like the torque, like the turning moment. So we can write it as r cap into the force cap. Sorry, r vector into the force vector. So we know the displacement vector cross product with the force vector. It is going to be your moment. Okay, now what is going to be your r vector? So see, this is the displacement vector. So 2 points are given, 2 0 minus 3 and 2 minus 2 and minus 2. Okay, so what we can do, guys, what we can do, so we can take the moment about this, so we can find the displacement vector along these 2 points. So let's suppose this is A and this is B. Okay, so what is going to be the displacement vector? So what we do, so to find the displacement vector between 2 points, what we do, so we do like this: x2 minus x1 I cap plus y2 minus y1 j cap, okay, plus z2 minus z1 k cap. This is how we proceed. So this is the formula for the displacement vector. So we can find the displacement vector very simply. Let's do it directly. So 2 minus 2, it is 0 of I cap. Okay, let's write it here itself. Then minus 2 and minus 2 plus 0. Minus 2, minus 2, minus 0. Okay, okay. Or actually this is B minus A I have to do now. Sorry, so A minus B I have to do, because see, this moment of the force at this. Okay, so the force is at this point and the point is this. So I must consider, I have to consider what? I have to consider this as B and this as A, right? Okay. because the force is at this point and we are taking the moment about this point. Are you getting my point? Okay, so we need to do B minus A. Okay, sorry. Yeah, B minus A. So B minus A, so again I'll do, so 2 minus 2, that is 0, I cap, okay, plus 0 minus of minus 2, that is 0 minus of minus 2, that is plus 2 J cap. Then we have minus 3 plus 2, minus 3 and plus 2, that is minus K cap. So this is going to be your R vector. Okay, see, I just find the displacement vector between these 2 points. So 2 points are there, na, A and B, and the force is at B. Okay, so let's suppose some point is here at A, and the force is acting at the point B. I don't know the direction, but let's suppose the direction is this. Okay, the direction is this. So this is the force vector, and if I join these two lines, this will be the displacement vector, that is R vector. So we need to do AB, AB your displacement vector. So that is the position vector of B minus position vector of A. Okay. Now this way, what I did, I have subtracted the x component of B with x component of A, y component of B with y component of A, z component of B with z component of A. Right? So it will be 2 minus 2, 0, 0 minus minus 2, that is plus 2, minus 3 minus of minus 2, that is minus 3 plus 2, that is minus K cap, right? And we have to do the cross product with force. Force vector is already given, 4 I cap plus 5 J cap minus 6 of K cap, right? So this is the cross product. So how we are going to get the solution for it? So we can use the determinant method, that is I cap, J cap, K cap, okay? And this is going to be 0, 2, minus 1, 4, 5, minus 6. Okay, 4, 5 and minus 6. So this is going to become, see, I cap, then this is 6 minus 2, that is minus of 12, and minus of 5, that is plus 5. Okay, so do we lead to the answer? No sir, not yet. Now afterwards we have minus of J cap, minus of J cap, then this is going to be 0, 6, 0 minus 6, that is 0, 0 minus 6, 0 minus 6, that is going to become 0, okay, 0 minus 6, that is 0, then minus of minus 4, so minus of minus 4, it will become plus 4, okay. Now do we reach the answer? Yes sir, we reach the answer. It is minus 7 I cap. Now we'll have something of K cap also, but do we need to find it? No sir, we'll come to the right answer. So this has to be minus 7 I cap minus 4 J cap. See, always keep seeing the options. Okay, this way you will end up saving some time. Okay. Okay, so obviously it will come out to be minus K cap. So what is the answer to this solution? The answer is A option. Right? Okay, I write. So just have a look at it. Okay. So I have stopped my video so that you can see the solution. Okay, because sometimes like in a flow I forget that I am also there on the screen, right? So I cap we have minus 12 plus 5. Okay, J cap we have 0 minus minus 4, that is plus 4. So as soon as I get minus 7 I minus 4J, I can give the answer, that is the C option. I hope it is fine to everyone. Okay, so here in this question basically we use the concept that we have learned in the chapter of vector. Okay, now let's try this one. Let's see if we are able to do it. Let's try it. I'm very sure we can do it. Let's try it. Please do it, Buddha. So now, before you solve this, okay, I'll just give you a mathematical formula. The basic trigonometric equations you must also know. So cos A minus A by 2. Just giving you the formula so that if you don't know the formula, you can still solve this question. that is cos A by 2, cos A by 2, right? Plus sin A by 2. Okay, now you can try to solve this question. Let's go for it. Okay, so I have given you a mathematical expression here. Okay, so if you find any use of this equation, you can do. Please go for it. Please go for it. I'm very sure we can do. Let's try this one. Please do it. Let's try it. Let's try this question. The live students can respond to me, Vida. Please go for it. Please try it. Very simple question. You just have to remember something. This is a previous year NEET question. See, how can we do it? So it says if vectors A and vector B are functions of time, then the value of t at which they are orthogonal to each other is. Okay. So two vectors, when they are orthogonal to each other, their dot product becomes 0. We know that. Okay. Two vectors, when they are orthogonal to each other, their dot product becomes 0. If they are perpendicular to each other, their cross product becomes 0. This is what we have learned. So if I write the dot product of A vector with the B vector, this is going to be 0. Now finding the dot product, what it is going to be. So it will become cos omega t. See, I'll multiply the I together, then we'll multiply the j together. So it will become cos omega t by 2 plus sin omega t and sin omega t by 2, and this is 0. So if I say this omega t, say, now if we compare this formula with this very equation, can I write it as this c? Now if I compare A is omega t, so can I write cos omega t minus omega t by 2? I have considered A as omega t. This is 0. So what is 0? So 0 means cos pi by 2. Pi by 2. So if I compare these angles, now if I compare, so we know that cos 90 is cos pi by 2. Now if we compare these angles, what we are going to get? Omega t by 2 is equal to pi by 2. Is equal to pi by 2. So what are we getting from here? So we are getting t is equal to pi by omega. So that is going to be your answer for this question. Isn't it? Right? We are getting b is equal to t is equal to pi by omega. Is it fine, Bra? Right? The live student can respond to me. Is it clear? Is it clear? The live student. The live student. Now let's try this question. Please try this one. Let's see if we are able to do it or not. Please go for it. Please go for it. The live students can answer to me. Please go for it, Vida. Please go for it. Any answer? The live student can answer me. Please try it, Vida. Very good, she said. So it says a particle is moving such that its position coordinate x and y are. So position coordinates are mentioned here. So position a particle moving in such that its position coordinate are this and this. Average velocity vector. So what is average velocity vector? So velocity is displacement per unit time, right? Displacement per unit time. So from t0 to t5. So t0. So when t is equal to 0, x1 I can say that this is 2 and y1 I can say this is 3. And when t is equal to 5, x1 x2 can be say at 13 and y2 we can say that is 14. So what is going to be the displacement vector? Hello Shita. What is going to be the displacement vector? So displacement vector is going to be difference of the x coordinate with I cap, difference of the y coordinate with j cap. So it will become 11 of I cap plus 11 of j cap divided by time. So what is the time? Time is 5 seconds. So which option matches? D option matches here, isn't it? Yeah, very easy question, right? Right? Okay, let's try this one. Let's try this one. Please go for it, Bida. Yeah, please take some time, no problem. See the concept of the concept of the vectors are applied at many places and many physical phenomena. Let's do it. Please go for it. You cannot do. See, you don't need any information of charge, electrostatics, or something like that. All you have to do, you simply have to, 9 will never be the answer. Hmm? Acha. How you know? Okay, so let that's okay. So see, you simply have to apply the fundamental of the vectors. Okay. See, 2 point charges Q1 and Q2 are placed at 0, 0, 0, 1, 2, 2 meters. So I don't know where is 1, where is 2. Let's suppose that 1 is here and 2 is here. These are the two charges. Its coordinate is mentioned 0, 0, 0. Its coordinate is mentioned 1, 2, 2. They repel each other with a force of 3 newtons. So they repel each other. So if I say that the force will be, so I can write it as force F21. So this is the standard notion. See, F21 it is written, so it is the force on 2 due to 1. This is how it sounds. So when we write F21, this is the force on charge 2 due to 1. That is why we write it in F21. Now you tell me one thing. You tell me one thing. This force is a vector, beta. Just see, you have to be sticking to your basic. This force is a vector, so you require a magnitude of it. So magnitude is given 3 Newton, and you require a direction of it. You require a direction of it. Now, do you realize that direction of this force is going to be in the same direction in which 1 and 2 lie, right? Isn't it? Do you understand? This is the only click in this question. See, we have two charges, they repel each other. Okay, so they will repel each other, but the direction will be this now. Okay, so one charge will repel the force in this charge that is in the direction of 1 to 2. Do you agree or not? So the direction. So if I say this is point A, this is B. Okay, so direction, there is only one thing that gives direction in physics, that is unit vector. That is why I keep telling you, unit vector is very, very important. It has a lot of uses in physics, right? So see, you have the magnitude, you have the direction now. So this force have to be, this force must be in the direction of A and B. Okay, so we can find the direction of AB by finding the AB vector. So what is going to be the AB vector? So AB vector is going to be 1 I cap C. Simply, when you are finding the displacement vector, x2 minus x1, y2 minus y1, z2 minus z1 with I, j, and k, plus 2 j cap plus 2 k cap. Isn't it? Isn't it? So can I write this AB cap? So what is this AB cap? This is going to be AB vector. So it is going to be 1 I cap plus 2 j cap plus 2k cap divided by magnitude of this AB vector. So this is 1 square plus 2 square plus 2 square. So that is 9. So root 9 and 3 will be cancelled out. So this F21 is coming out to be I plus 2j cap plus 2k cap. Okay. Now if you compare it with this xi plus yj plus zk. So x is 1, y is 2, z is 2. So x is 1, y is 2, z is 2. That means it is going to become equal to 5. Is that clear, beta? Isn't it? No, no, it is 5 now. This 3 and by root 9 will be cancelled out, isn't it? And then we have to compare it with I cap plus y j cap plus z k cap, isn't it? So obviously x is 1. If you compare these two, x is 1, y is 2, z is 2. Please tell me if you agree to it or not. Please answer me, Buddha. Right. Okay, understood. Good question. Yeah, wonderful. Children, let's try this one. Let's try this one. Please go for it. Hmm. Very good, she said. So very simply, it can you can say this is B cross C. See, simply either you can take vector triplet, but you can see it directly now. So A dot B is 0. That means B is perpendicular to A. A dot C is 0. That is C is perpendicular to A. That means B and C are parallel. B and C are parallel. Okay. Now cross product of two vectors. Cross product of two vectors in a parallel will give the direction perpendicular to that vector. Okay. Will give the direction perpendicular to that vector. Now we know cross product of two vectors will have the direction in the perpendicular. Okay. Okay. So this is when we are doing B cross C vector. Let's suppose it's come out to be D vector. So this D vector is perpendicular to both B and C. So perpendicular to both B and C, that means it is parallel to A vector. Isn't it? Right? Okay. Very simply we could do. So this is what we have done in the section. Let's have a look at it also. Let's try this one. You are saying something, but both three of them can also be perpendicular. No, no. So you can then use the see. I didn't tell you the triplet vector logic. Okay. A dot B cross C. Okay. If it is equal to 0, then this is perpendicular. So I just given you a logic that there cannot be any answer other than this if you see through the option. Okay. Now let's try this one. Hmm. No, no, you are right only. But see, I didn't want you to. So if you check other options also, na, so this logic. Otherwise, you can go by the vector triplet logic, right? But I didn't want you to do that. That is the reason. Nothing else. So this is what we have done in the session. Na? If the angle between two vectors is theta and the value of product B cross A with A dot, so cross product with dot product, it is going to be equal to 0, right? Right away we know it is. So let's move to the next question. Very easy question this is. Let's try this one. Yeah. So these are just PYQs. Let's try it. Very simple, isn't it? So A cross B. So A cross B, that is AB sine theta, and root 3 A dot B, that is AB cos theta. So tan theta is equal to root by root 3. So tan theta is root 3, that is 60 degree. Okay. Okay. So we now can do some of the questions. Okay. So last session we did with the projectile motion. Now let's have a few questions of projectile motion. Let's try this. Very, very simple. Very, last session we have seen this thing. So what happens if it is 2 I cap plus 3 j cap? So what is the component here? So this is going to be 2, this is 3. Okay. Now in this, so we know that horizontal component don't change, and here the vertical velocity will be 3 downwards. So what it will be? It will be 2 I cap minus 3 j cap. So simply the B option, right? See, this is how the questions in NEET are getting asked. Very simple question. Like I can see most of the projectile questions that are here, we have done in our regular session like this. Please answer me right away. And meanwhile you answer it, I'll just write one more question here. Hmm. So last session we did this question, isn't it? Okay, the horizontal range and maximum height are same. So when H and R are the same, okay, in that case the theta was tan inverse 1 by 4, right? You remember that, no? You remember that, right? This is something we have done in the last session. Did we or didn't we? Right. So horizontal range and maximum height are the same. So what is the horizontal maximum height? It is u square by sine square theta upon 2g, and it is u square sine 2 theta upon g, right? Now from here we'll get see sine square theta. So those who haven't attended the regular session, if you are watching this video, so it will become 2 by 2 cos theta sine theta, right? So this will become sine theta 1 sine theta will be cancelled out, and we'll get tan theta is equal to 4. Yeah, sorry, it's B. Yeah, my mistake. It is B. Okay, tan inverse 4. Right? Yeah, sorry. Tan inverse 4. Okay, this is what we have seen. So I was just writing one question. So a missile is fired for maximum range. A missile is fired for maximum range. Let's see if we can figure it out. With initial velocity, with initial. So as I said in the last session, we'll do the question of projectile in this session. Okay. So I think we can have the practice here. So velocity of 20 meter per second. Okay. Now if g we consider as 10 meter per second square, let's suppose g is 10 meter per second square, the range of the missile is, the range of the missile is, see, very simple question, 40 meter, b is 50 meter, c is 60, and d is 20 meters. So how we can do this question, beta? So a missile is fired for maximum range with initial, so it says maximum range. So in the last session what we have done, sir, so we have seen when maximum range is there, theta is 45, isn't it? When it is of maximum range, the theta is 45 degree, right? Theta is 45 degree. Now if theta is 45, what is the range? So range is going to be u square by g, because sine 2 theta will become 90, right? Now if at all we don't know that also, now if you see this expression that r is equal to u square sine 2 theta by g, so it will be maximum only when sine 2 theta is maximum. And what is the maximum value of sine, no matter what angle is in within the sine, right? So maximum value of sine is always 1. So you can right away write u square by g. So what is u? U is given to be 20. Okay, so it is going to be 400 upon g. G we can consider as 10. So it is going to be equal to 40 meter. Fine, beta? Yeah? Yeah? So similar question. There. So I can see one more question. Shailesh, very good afternoon, beta. So the session is about to end. So one last question of projectile, because I can see. So I'll see if I have some more questions. I'll just write one. So two bodies of same mass. Hey, Madhuri, very good afternoon, beta. So two bodies of same mass are projected. So in the last session we have done the projectile motion to some extent. So we have solved some question. Now I'll just utilize this session to solve a few more questions of that with the same velocity, with the same velocity at 30 degree and 60 degree. Okay, respectively. The ratio of their horizontal ranges So these are the concepts where what we have seen in the last session. Now. So 1 is to 1, 1 is to 2, 1 is to 3, and 1 is to root 3. Yeah. Let's try this question. I'm very sure we can do it. Please go for it. Can you please try it? What about you, Himadri and Salish? Himadri and Salish, what is your answer, beta? So two bodies of same mass are projected with the same velocity of 30 degree and 60 degree respectively. The ratio of their horizontal ranges. So what is the ratio? Now one angle is 30, one angle is 60. So yesterday what we have learned that if the angle is theta and another angle is 90 minus theta, so if two bodies are projected at the angles of theta and 90 minus theta, you are going to get the same horizontal range. This is what we have learned in the last session and we have proved it. Okay, so this is 1 is to 1. You can see it here also. See, R is equal to U square sine U square sine 2 theta upon G. Okay, now if you put instead of theta, if you put 90 minus theta also, so this will become 180 minus 2 theta, and sine 180 minus theta is nothing but sine theta. So you will be getting U square sine 2 theta by G. So what happens, beta? What happens? So when two bodies are projected at an angle of two body of same bars are projected at an angle of theta and 90 minus theta, the horizontal range is going to be same. Let's try these questions. So the second question we already have done, no? So angle between A cross B, so this is 0, na? Dot product of cross product of these two is going to be 0. Okay, let's try this question. What about the rest of you, beta? Can you answer it? Let's try to answer it. Hmm. What about the rest of you, beta? See, these are the questions of vectors. Let's try them. Any answers? So see, I kept telling you this. So the cross product of two vectors is always a vector. So when you find the resultant of A cross 0, it will be a 0 vector. This is something I have told you like a number of times, isn't it? Right? Okay. Now let's move to the next question. So let's do some more questions. Okay. Let's try this one. Very simple question. Please go for it. Wrong answer, she's saying. It seems that you have made some silly mistake. Now you have given the right answer. What about the rest of you? So see, the angle between the two vectors. So what is the angle between the two vectors? The A vector dot B vector. It is equal to mod of A mod of B cos theta. So we can write cos theta is equal to dot product of A and B. So what is the dot product? So I component multiplied with I, J component multiplied with J, K component multiplied with K divided by uh, A mod, B mod. So this is going to be 0. Okay, this is going to be 0. So when it is going to be 0, so theta is 0, cos theta is 0, that means theta is 90 degrees. Clear? Yes or no? Right. Yeah, let's try this one. So rest of the students, so have you completed these chapters like vector, kinematics, projectile? Have you done those? Because if you haven't done those, definitely you might be feeling some problems, right? But if you want to complete it, you can check this channel. Okay, so I have completed each topics like motion in a straight line, vectors. All these are completed to a great extent. So we are asked to find the power. So what is the power? What is the power? So power is force dot product with the velocity. Okay. Okay. So I told you this that the power is the scalar quantity. So when two vectors multiplied and you are getting a scalar quantity, that means you are going to do a dot product. So when I do the dot product, what I'll be getting? So 20 into 6, that is 120 right away. 15 into 4, that is 60. And this is 15. Okay. So this is going to be 45 joule per second. So we are going to get the A option. Clear? Let's try one more. Please go for it. Represent the previous this one. Yeah, please have a look. Or this one. This one you are talking about, beta? This side? Any doubt is there? This one? The vector one? Please have a look. Any issues? Any issues? Shall I proceed? Can you try this one now? Let's try this. Why your friends are not here today? Yeah, please ask me the doubt, beta. If it is related to the chapters we are discussing, I'm more than happy to answer. Oh, yes, yes. Okay, Shivai. Hey, what is your doubt, beta? See, this is beyond my knowledge. I don't have any understanding of biology if it because I understand this is not a question of physics. I'm an engineer, beta. I don't know this. Right? I'm really sorry. You can come in Harsh's class, he definitely be able to answer you. Okay? Harsh sir is the biology educator, he'll be answering you. Even I don't know it. I don't know this. I have no idea. Okay? So this is the question, okay? So what is the linear velocity if angular velocity? Yeah, just leave it. I don't know the answer and I don't know. So what is the linear velocity if angular velocity and position vector are this? So see v vector. So what is the answer you have given? C you have given. Okay. So v vector, remember this is omega cross r, not cross r cross omega. Right? This is also very important in cross product. So v vector is omega vector cross r vector. So it is going to be 3 I cap. So I'll just do the determinant form right away. So we know that we can find it in determinant. So I j k. So 3 minus 4, 1, and this is 5 minus 6 and 6. 5 minus 6 and 6. So what it is going to become? It is going to become minus 24 minus 24 and minus minus plus 6. So we need not to do any further. This is going to be minus 18 I cap, right? So the in cross product, this is also very important. Okay. So like for torque, that is R vector cross force vector. But for, so we all know V is equal to R omega. V is equal to R omega. So when V is equal to R omega, V is equal to R omega, this is V is equal to R omega. Okay. Okay. So V is equal to R omega in general we know, but it is actually in the vector form omega cross R. Okay. I hope it is fine to everyone. Now let's try one this question. Okay, let's try this one. Please don't get into such discussions. See, it is advisable all of you to stick to the topic. This is a physics class, and we are solving the question. So it is best for all of us that we stick to the content of the video. Okay. Okay. So let's have a try. Let's give it a try. So find the torque of a force F acting at the R. So see, this is torque. It is going to be R vector cross force vector. So R vector cross force vector. So we can simply do I, J, K. They will solve the complete question. Just try to look in the options also. So 7, 3, 1 minus 3. This is the benefit of having the option. So I, it is going to be for 15 minus 1. That is 14. Okay. This is the option. Right. Okay. Let's try this one. Last question for the day. So in the next session, we'll be trying to deal with the relative velocity in one dimension. Let's try to do this. Yeah. So it says a body constrained to move in y direction is subjected to a force given by. So we know that the work done is the dot product of F and displacement. So it is moving in 10 meter along y direction. So work done is going to be, so F vector, that is, so let's have this F vector. And what is this D vector? So 10 meter along y axis. So this is going to be 10 of J cap. Now I can see, so I cap, so 15 into 10. So if you write this vector here and you multiply it with 10, it is 150, very good, Joule. So that is going to be C option, right? Right? So guys, in this session, we have solved a lot of questions. Let's see how many we solved. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 questions we have done today. Yeah, 17 questions we have done today. So let's meet each other in the next session and yeah, in 1 hour. So in the next session, we'll be dealing with the relative velocity in one dimension. So very interesting chapter. Okay. Okay. And we are going to talk about it. Very good. So guys, the new students who are joining the session, I request you to subscribe the channel and please follow all the sessions here. Okay. So with this, thank you very much. Have a good day. And I'm going to see you in next 15 minutes with a new session of relative velocity in one dimension. And that will be the end of motion in the straight line.